And this is what I will try to explain to you how we can do that. Again, if you look now backwards, what we have done, that could have been done 50 years ago. So in principle, it's based on very simple ideas. This here shows, in principle, what we do in order to modify the defect in chemical structure in crystalline solids. If we take a melt and we cool it slowly, I'm talking about atomic or molecular melt, not macromolecular things, and we solidify it slowly, we get a perfect crystal without any defects. However, what we can also do, we can introduce defects by taking very tiny crystals and bring them together, and then a few nanometers in size, then we get lots of these defects into our material, and these defects will dramatically change the properties and the structure, because the atomic arrangement here is different from what it is here. And that's the basic idea of nanocrystalline materials. And of course, also we can introduce defects, structural defects and chemical defects, by taking tiny nanometer-sized crystals of different chemical compositions, bring them together. Then what we get is a multi-phase nanocrystalline material, and this is a single-phase nanocrystalline material. I was showing you some example things. Now, the situation in glass is quite different. You take the melt and you quench it, and you inherit the structure of the melt, and then this is what you call a glass, a non-crystalline solid. This is what you find in your textbook. Now, the obvious thing is to do, let's try to copy this here, and then we should get a new kind of glasses. And this is what we did. And in principle, the idea is very simple. Instead of solidifying the entire block of a liquid, we solidify tiny droplets. And then we get tiny glassy regions similar to these tiny crystals, and then we bring them together, and this is what we call a nanoglass. And this nanoglass then consists of these glassy regions, and then interfaces in between, where you bring the droplets together, atoms do not match, and therefore you get a region where you have misfit similar to a grain boundary, but now between glassy regions. And of course, you can repeat this one here by taking a silicon dioxide glass, tiny droplet, and a metallic glass, tiny droplet together. Then you get a multi-phase nanoglass. Of course, you couldn't do that from the melt. So what the textbook tells you, you have to stop here, and this is what we did the last 13,000 years. And this is the part which is almost trivial, but this is what helped us to get away. Now, so far, this is all on paper. The question is, what do we see if we do it in reality? And this is what I want to show you.